So really excited to be here. I'm a data scientist at Nexgate, and my background's in particle physics. So in the Valley, that's sometimes people call that YAP. I've heard that before, which is yet another particle physics. So I'm going to be talking about Cassandra here at Nexgate, and it's going to be kind of a story about how we moved from to a NoSQL solution. So what is Nexgate? Just want to give you kind of a background first. Does anyone know, suppose you were a Fortune 100 company, how many social media accounts do you think represent your brand if you were a Fortune 100 company? So let's kind of just focus on Facebook pages first. Anyone have a guess on how many Facebook pages your brand might be represented by? Any quick guess on the number, or maybe 2, 10? Well, 5? Yeah, well, it turns out to be 300, around 300 accounts, and that's just that's just Facebook. So when you throw in Twitter, LinkedIn, Google+, YouTube, that's a lot more. So imagine trying to sift through all this content and trying to manually kind of classify it. So there's a lot of stuff that's on there that doesn't belong on there. So you have bad actors on Facebook pages. They're trying to harm sort of other users, your audience members on your Facebook page, and stuff like that. So they're kind of diluting the message that your brand's trying to present to the audience. So Nexgate, it's a technological solution to help you discover the accounts that you have, helps you protect it. So you might be seeing some hacked accounts lately in the news, like the White House Twitter account was hacked a couple years ago. There was a bomb threat. Celebrity Twitter accounts get hacked all the time. So we help protect that. Also monitoring them. If you were a school, for instance, you might not want hate speech on there or cyberbullying. If you're a financial institution, you don't want content posted on Facebook that violates FINRA or FFIEC, or if you're a pharmaceutical, you don't want HIPAA violations. So we offer automatic classification of your content. And so there's over 100 categories that we do. And so also a little bit about the team behind Nexgate. So we're a startup, and we launched about a year and a half ago, around 18 employees, so kind of a small company. So we're going to talk about how we use Cassandra as a small company. But collectively, the co-founders and the employers have dozens of years of experience in security. And over a year and a half, these are the type of customers that are taking social media very seriously. So that's pretty good, I think, for being around for a year and a half. So talking about the scale of the data a little bit, there's over 350 million pieces of social media content spread across Facebook, YouTube, LinkedIn, Twitter, etc. And if you were to ask me 4 months ago what that number would be, it'd be 250 million. So we're growing, the data that's coming in is growing exponentially. So the rate that today is 1.5 million new content per day, and it's all classified in real time as it comes in. And there's 65 million total social media authors. That means people who are posting on social media, and then it's about 250,000 new authors a day. So that's kind of data to give you an idea. All right. So the machine learning experts and statisticians in the room know that in order to have a good classification system, you need to have a lot of data. So in order to have a lot of data, you also need a strong infrastructure. So I like to sort of give a quote by Rich, our CTO, is that the completeness of any classification system is predicated on the breadth of the corpus of data upon which it's built. So that means that, think of email, spam, and ham. It takes a lot of data to be able to do that correctly. So imagine if you had 100 categories. So not only do you need breadth, but you also need depth for those categories as well. So you need to collect a lot of data, and we need to have a strong and capable infrastructure in order to do so. So we'll talk about how we got to that infrastructure. So in the very beginning, we threw everything into MySQL, and why not? It's easy to use as a startup, and you try to launch quickly. You want to use a tool that gets the job done, and many people already know it. So it's easy to kind of hire anyone off the street, and they'll be able to use MySQL. It's very, very easy to use. Also very secure. The banks are using SQL. It's been around for a while. A lot of security issues have been known. It's also inexpensive. You can't do much better than free for MySQL unless people pay you to use it. It manages memory very well, And up to 50 million rows, you could have pretty fast queries. So starting out, it's a great solution. It also supports several development interfaces. So even though the trending topic of the day, trending framework of the day could be Rails, you know that it's probably going to have a SQL connector. And in fact, it does. So it's not to say that MySQL is a dumpster, even though the picture is that. We heavily rely on it for our success. There's this, one does not simply alter a table in MySQL. So after several months, where we realized that our data model wasn't handling all the scenarios, and we needed something else, we needed to move to a NoSQL solution. And to talk about the kind of data we have before we talk about NoSQL, pretty much social media data size on average is about 1K. That includes content and metadata. So you're familiar with sort of the content on Facebook and Twitter. It's just kind of like simple phrase or two, a sentence maybe, and maybe some links. So that's kind of the content. And the metadata is the stuff around that, so the timestamps, who it's posted by, what account it's on, and things like that. So the metadata can also vary depending on what platform you're on. So for instance, engagement activity, like for Facebook, you have likes. For Twitter, you might have followers, and YouTube subscribers. So social media data is pretty rough and jagged, and you want to store some of it in a flexible database. So you want to store actually in both SQL and NoSQL. So you don't want to sort of take all your data in SQL and store it in NoSQL. You still want to use the right tool for the job. There are some cases that you want to store your data in SQL. So for these cases, it's things like fixed length, non-null, heavily indexed. So things like the timestamp or the author ID, it's going to be there for every content you have, no matter what platform. So it's good to store that stuff in a relational database. For other things that are more variable length, commonly null, that you're going to access only once, you don't have to worry about joining against another table, you want to store it in a NoSQL solution. So different authors might be posting different number of times. Each account might have a different number of authors. So these are all kind of variable length variables that you can store in a NoSQL solution. So when we looked around for a NoSQL solution, we had a couple of requirements in mind. And so, I mean, the punchline is we're at a Cassandra summit, so you kind of know what we chose in the end. It's Cassandra. And so as we go along one of these bullet points, I'll kind of say why Cassandra fit that use case. So it's easy to use. It's actually very easy to use because in my case, coming from an academic background, the very first day, before I knew kind of MySQL even, relational database, I was put on a task to make a web app using Cassandra as a backend. And in one day, it's very easy to learn how to put data into it, create a data model, and get data out of it. So very, very easy to use. And the second day, I was making composite columns. And we wanted something that would scale horizontally. And so like if you had a cluster and you had a server and you fired it up, this cluster would magically know that server's there, and then you would have a new node in your cluster. So you wanted something that was simple and proven, and Cassandra is just that. We also wanted some integrated tools for research because we rely on our classifiers, so we wanted to be able to do search and analysis easily. So Solar provided that. We wanted operational simplicity so that all nodes are the same. There's no knock on having a master node, but we didn't want to worry about if a node went down, is that the master node or the gateway? We just wanted everything sort of to handle itself. And so the gossip protocol on Cassandra was great. Fantastic support, enterprise support. So obviously DataStax provided that, and I'll talk a little bit about how they helped us in a bit. It's simple to deploy and maintain. So a couple of weeks ago on AWS, I was able to make 5 clicks and put a command line, and my Cassandra cluster went up in 2 minutes. So it took longer for it to fire up than for me to get it to fire up. So it's very easy to deploy. And in terms of maintaining it, I mean, there have been a few support issues, but not very big and not very long, and few and far in between. So that was good. Integration with other big data tools. So at the time, we noticed that there was integration with Hadoop. So there was CFS was being actively developed, which is the Cassandra file system. It's kind of like the HDFS version in Hadoop ecosystem. And so that was great. You didn't have to worry about doing your batch processing and transferring the data over to Cassandra. You could just do it straight on Cassandra. So that was great. And these days, the shiny new tool is Spark, and we're really excited about that as well. All right, so this is a picture from the Ops Center, and just to give you an idea of how it looks for us. The previous speaker had a tweet about, if you start up 3 nodes, that's kind of what we have here, 3 nodes. We have 1 node in the east, and the reason why we have the multi-region clusters is because, if there's an earthquake in Napa on the west coast, you still have your data available on the east. So we use M1 large instances, and we're about to scale again. We have a separate cluster for dev, test, and production so that we can throw data and see how it works. So yeah, DataStax has been extremely helpful in supporting us. Obviously, this is the Ops Center created by DataStax, so they've been extremely responsive. So just to look at some of the monitoring tools for DataStax. So we have about 70 reads a second and about 25 writes a second. And you might have been reading that Cassandra is really good on writes, and in fact it is. We just have a high number of reads because we do real-time analysis on the data that comes in, so we require a bit of reading as the data comes in our classification. And so that's why the number is high on the reads. Okay, so I mentioned before that we have over 100 categories, and one of them is spam. And I want to go into sort of a use case and how we detect spam using Cassandra, and sort of like a little bit of data modeling here. So spam's been around for a long time. You all know what spam is. The first time it was recorded in the Telegraph, actually. So even before email, there was spam in the Telegraph. And everyone is extremely familiar with spam now. You know not to open an email from someone you don't know, never download any executable files, and if there's words like Viagra or Nigerian prince, you know you're not going to believe what the email says. So the point is that there's a lot of great infrastructure around it. So Gmail does a great job at that, but social media is sort of the new medium, and attackers and hackers are taking advantage of social media. And so it might be worth kind of talking about what kind of spam there is in social media. So you might get something like this, just a simple link. And the link says visits2money.com. Now that might be a little obvious because you can read that. And the most common types of spams that we see actually are ways to make money easily, work from home schemes, weight loss, also apps. We also see a lot of spammy apps where it promises that it could do something to your profile that you can't normally do through Facebook. So for instance, change the color theme on your profile, or see who's visited your profile. So these are a lot of common spammy apps. But the catch is, the thing is, sometimes the link is not straightforward. You can't see what's behind the link. There's a lot of link shorteners. For instance, Twitter has the character limit, and so you might get a link shortener and you don't know where it's going to, and you might click it, and you might go to a phishing site or a malware site. So there's a lot of danger there. People aren't kind of aware yet as they are in email. Besides links, you might get some personal message spam. So people can be, the attackers can be very clever. They might send you a very personal note to which you reply. So here's an example of a message that's been sent to 2 different accounts, even though it's the same message. So they can send you a message and you can start a conversation, and then it might entice you into falling for one of their traps. So we want to be able to catch these messages using Cassandra, and so we'll talk about that in a little bit. But we did release a social media spam report. I encourage you to take a look at it if you kind of want to get educated about social media spam. But that was back in 2013, and since then it's grown about 7 times. So spam is becoming a real problem. You can create spam signatures to catch the type of content by looking at things like work from home or things like that. But you could only do that after the fact. So that creating these signatures would take too long, and it'd be too slow to catch in real time. So Cassandra to the rescue. So how do we do this? So I'll kind of walk you through a data model of how we catch spam in real time. So even though Cassandra is a NoSQL solution, you can't just throw data at it and hope that your query is going to work out. As you've been hearing over and over again, you have to define the data model based on how you're going to query it. So for us, we want to determine the number of times a certain content's been posted. Because spammers tend to post same content messages. So how do we do that? A typical table in Cassandra could look like the following. You might have a row key and the column names after it, or you might have composite columns. So the row key could be, say the hash of the content that comes in, so the social media post, that could be MD5 put as the row key. And then the column name could be the unique ID of the post. So each social media platform has an ID associated with its content. So the comments are also with comments that come later, the ID increases. So if you store the IDs this way, you also have the comments ordered by time. In the item value, you could have more information such as another item ID, which is a variable that we use internally, and then the time of the post. So this is how kind of this is how we defined our data model in Cassandra, and we'll see how this can help us catch multiplicity posts. So again, spammers typically post the same content over and over, as you saw before. It's very easy to determine how many times a post has been made using that data model. All you have to do is count the number of columns. So because you've hashed your content in the row, every time you see a new post, it's going to add another column. Sorry, a new post with the same content, it'll add another column. And you'll never double count because it'll overwrite a column because the ID will be the same. So it's pretty fast because you're indexing by the row key. And then you could also extract valuable time series information from this too. So remember that we stored the item ID and the time of the post. So the time of the post you can look at to see if there's a burst in activity from the spammer or if there's regular intervals of posting. So these can all be really great indicators of spammer. Item ID can also tell you if it's the same author that's posting the content or maybe it's different authors, which is more interesting because maybe that's the same person in real life. So you can get a lot of information from just this very simple data model in Cassandra. With that said, Cassandra's not a magic bullet, and it won't solve everything. So you still need a relational database to glue all the pieces of data together, such as who's the parent of that post, if it's a reply to a certain comment or something like that. And you also, you don't have batch processing on Cassandra. So you might need to look into other tools like Hadoop. So after we implemented this data model, we sat back and then we saw what happened. So brace yourself, spam is coming. We actually saw a post that came in 38 times the day after this was implemented. So this was a post that made over and over 38 times in a day. So it's something that, spam is defined as something that's sent a lot over and over again. And so this is definitely spam. It's something that the brand would want to remove from their wall. It's not adding any value to anyone. In another case, we also saw a customer receive 25,000 types of inappropriate messages, and it also helped remove it. So with the simple data model, a lot of value was added. So it's really important to keep all the data. And another way that Cassandra has helped us is by tracking down spammy users. So that's spammy content. To identify spammy users, we have to know all the posts that a person has ever made. So what we do is we look at the post to see if it's spammy. If a person's spammed a certain number of times, then they're a spammy user. So from that point forward, every time they make a post, it's spam. So Cassandra is nice because you can throw data at it easily. It's readily accessible, and you can make these kind of queries on it in real time. Additionally, besides the spammy users and the spammy content itself, it's important to keep all the data to train our 100+ classifiers. So tuning Cassandra, it's actually been humming along quite nicely. We barely had to tweak anything from the default values, and we don't have a lot of deletes. It's just kind of the nature of our data set. And whenever you do deletes, that's when you have to do repairs because you're repairing the inconsistencies across the replicas of data due to deletes. Yeah. Yeah, so it's a web app, but you can install it through Facebook. So it would look like a Facebook app. Yeah. Yeah. Okay. So again, not a lot of tuning needed, and so not a lot of deletes. For us, that's great. So there's not a lot of intensive disk I/O. There's only a few times that we observe performance issues, and these are the times is when the rates of our reads and writes reach a certain threshold, when the size of the data being inserted was too large, or a heap memory issue with the Cassandra 1.1. But in all cases, when we asked DataStax, they jumped on within a couple hours and resolved it quickly. So that's been great. Cassandra community is wonderful. Obviously, you guys are all wonderful. It's easy to jump on IRC channel and talk to fellow users. In one story, we wanted to feature in a certain Ruby wrapper that we were using or a driver that we were using. And I was able to jump on IRC, and I had a conversation with the author himself, and he asked me to put in a pull request on GitHub, which I did, and then a week later, the feature was released in the next version. So it's very easy to talk to people actively developing Cassandra, and you can become a quick developer as well. Just to end with a couple of things, Ops Center has been extremely useful in helping debugging performance issues. Solar's been useful in looking to train our new categories as they come in, and then we're looking forward to using Spark to train our labeled data with MapReduce. So I encourage you guys to kind of take a look at us if you need to protect your social media accounts. And thanks very much.